ahead, guys, and start our review. Let's go. Before I go ahead and review, I want to make sure that you are looking at what your test is going to be looking like, guys. This is what your test is going to be, the calc test. It's how many questions? It's four. 1, 2, 3, 4 questions only. You're looking at them. Question number 1 is going to be related to is this what I gave you guys? No. Sorry. This is for this one. My apology. That's what I thought. Does it look anywhere? Okay. So, but you have different one. I thought I printed the wrong one. Okay. No, I just opened the wrong one. All right. That's easy. Okay. So let's go to test review number 2. There you go. I just opened the wrong one. Okay. So here's what yours is still 1, A, B, C, D, so 5, right? 1, 2, 3, 4, 5. 5 questions. The question number 1, guys, will be about a motor, and you need to find 6 things about this motor. Cool. We did this one. We're going to do it in a second here. Here's what I don't want you guys to get confused. I'm giving you 2 motors. I'm only picking one. So, Darren, don't go and volunteer to do the calculation for the other one. You understand? So there will be 2 versions. Some of you will be doing the 5, for example. Some of you will be doing the 10. The others will be doing the 5. Not 2 of them. Can I have thumbs up? We understand, Chad? All of them have 2 versions. So which one do you know? If I'm asking about the 10 horsepower, do you go to the 5 horsepower? No, just the 10. Everything going to the 10. Okay. The second one, we have feeder the power water heaters. Another example of the water heaters. And the third one is going to be electrical furnace. And the fourth one, my friends, electrical furnace, example about electrical furnace. The fourth one is going to be about AC units. And the last one, residential calculation. Step-by-step residential calculation. Cool? Everybody got that copy in front of you? Your test is going to look exactly like this tomorrow. All right, so let's go do it. Review. All right, so you guys got that one. So let's go and, all right, full screen. Okay, so here's question number 1. And I have all the information now. Remember, you don't need to draw all this for 2 reasons. Number 1, we went through it one time. Number 2, I'm going to PDF everything and put it on the network. Can I have thumbs up, Chad? When I'm done right now, I will PDF my calculation. If you guys want to follow with me with the calculation, the diagram, you will have it on a PDF file. Okay, just to expedite the process, give you enough time. Thumbs up, Chad. Cool. Okay. Okay, so let's so question number 1, and by the way, the number is related to A. So question number 1 will be A in your test. Okay, can you guys put 1 on it? I just want to A. This is an A. Okay, so I have a panel feeding 2 motors. Careless about motor 2. I only concerned about motor 1. It's a 10 horsepower. It's running at 208, and the voltage system is 208 123 phase. Does it matter? It's still, everybody knows 208 system. So it's a 208, single phase, 2 hots. And I need to find, starting with the conductor, the branch circuits, the overconduction device, the disconnect, the controller, as well as the overload. Can I have thumbs up, Chad? We understand fully. The only thing I changed from the example I gave you before, guys, is the voltage and the horsepower. I want to emphasize it's a 208 single phase. How can you get 208 single phase? Anybody can tell me? From a 208 3 phase. 208 123 phase can give you 3 phase and a neutral. So if you take any phase with a neutral, give you 120. If you take any 2 phases, get you 208. Still single phase. 2 hots, 2 phases. We don't call them 2 phases. We call them single phase, 2 hots. Cool? Any question? Everything we're using NM cable because we're doing residential. Any comments? Any questions about this, guys? Again, it's going to be PDF'd, and I'm going to go through the calculation. I have not done the calculation, so I need my A students to do the calc for these for me, please. My A students to do the calc. Do I have A students here, or did they disappear?
B minus is that.
Okay. All right. So, everybody understand what the situation is? What we're gonna do? You need more time to write things, or should I roll in? Roll in. All right. So the first thing we need to do, guys. The first thing that we need to do, and I have the advantage. I'm gonna be writing in green just because. The first thing I need to do for Brent circuit is take the 10 horsepower into table 430.248, and the voltage that I'm going to be looking at is 208, right? Under 208 because the system is 208, and go find the full load current for this boy. All right, so let me just help you. I already have this one right in here. I thought I did. Okay, so when you guys go to this table, I'm going to go back to that sheet in a second. When you go to this table, it's 10 horsepower, and the system is what? 208. So what do you guys think the full lamp for this 10 horsepower?
Yeah, we're doing 3-phase. Yeah.
It says 208 single phase.
It's 208 3-phase.
Good point, guys. Very good point. Before I leave this one, everybody knows. Well, I'll tell you that one. Why we went 10 to 8 here? Okay, so now you're very good, very good point. That's very confusing for a lot of people. Let's go back, guys. The system is 208 123 phase. The equipment is single phase. How? The system is the panel. But here's a good example. Here's a 3-phase panel. Is this a 3-phase load? Single phase load. Okay. So when you have the panel itself is a 3-phase 208 120 panel. The load that I'm giving you is 10 horsepower. Can you guys see single phase? Cool.
It just doesn't say that the motor is single phase.
It's right here, 10 horsepower. Oh, in your system?
It's just on the paper, it doesn't say that it's single phase. Right? The only thing it says is power system is 3-phase, but it doesn't say that.
Okay, I'll make it clear. Make it clear, guys, that it's a single phase. You are absolutely right. Otherwise, you will do it in 3-phase. Yeah, it is a single phase system. Very good point. In the paper, yeah, you're right. I should have wrote next to it single phase. I thought, no, I didn't do that. You got me. Absolutely, you're right. It's a 208 single phase. Okay, everybody got that one? All right, so we solved this issue. So let's go back into where we were. Right in here. Everybody can see, guys, 10, give me 55 amps. Everybody knows where the 55 amps came to be? Okay, from this table. Now let's go back, because single phase, back to where we were. So what was the amp here? 55 amps. Okay, then the code says, guys, and here's the reference, 430.22. The code says you take the 55. Now I need and multiply by 1.25. Who's my favorite A students who's going to do
68.75.
68.75.8. Any second?
Yeah.
Okay. So 55 times 1.25, what do you get? 68.8 amps. Cool. So we find the full load current. Here's there. I emphasize. I know, guys. I have the advantage of my stuff is here and yours is not. This will be PDF too. You're gonna have a copy of this one PDF. Cool. That's why I feel a little bit sorry for you. But PDF online, you can print that one at any time you want. So 55. If you just understand, here's the 10. 55 multiplied by 1.25 give you 68.8. Okay. Then you're gonna take the 68.8 amps. You're going to take it, because we're using NM cable, guys, this is 334.80 NM cable. You're going to take this one to which table? 230.15B16. And what conductor you're going to get? And 310.15B16. And which column? Anybody can tell me which column and why? 60. Why? Because it's an NM cable. It forces you to go to 60. Otherwise, I go to 75. Next quarter, I'm going to throw at you an MC cable. You go 75. That's the only difference. Okay. Anybody two agree on one answer? Number 4. So this is an NM cable. So 12.2. That will be number 4/1. 2. Why 2? It's a 4-2. Number 4-2. Why 2? It's a single phase, 2 hots. Do I need a neutral? No, it's a 2 hots. When we say 4-2, guys, does that mean it has any ground with it? Yes. So it's a 4-2 NMB cable. The worst that you can do to a motor, NMB cable. We're doing dwelling. Remember, we're doing dwelling.
No, sorry, HVAC chapter.
It's no, it's NM key inside NM is THHN actually. But if you put THHN in an NMB cable, that's great. Okay. Any comments? Any questions about that? See how easy that is. Now, overcome protection device, Aaron, my friend. Overcome protection device. Any question about the cables? When you guys graduate from here until we finish, doing calculation for a motor should be second hand for you, no question. Because we're going to be using them for the projects next quarter, the quarter after. You're going to get sick of doing this calculation. You get it one time, done. Okay, overcome protection device. For overcome protection device, you have an option. Do you guys remember this table? 430.52. Your options are, remember we're single phase, so here's a single phase. And my only option, and I'm using circuit breakers, that's your default unless you know otherwise. And what's my multiplier? 2.5. I hope you know how to go there. And if not, this will be PDF. You're going to find it. So you know where to go. Okay. So that's where the 2.5 came to be. Multiplied by 55. Who's my favorite A student who's going to give me an answer in another second? 2.5 times 55.
What table was that?
This is table 430.52. Is it here? Yeah, here. 430.52.
137.5.
Second, 137.5 amps. Okay, then, because they don't make 137.5 amp circuit breakers, we'll take 137.5, take it to 240.6. Everybody knows what 240.6? This is going to be to you, to us Minnesotans, is like saying Vikings. You don't know Vikings, you don't live in Minnesota. So 240.6, when you graduate from here, done with it, you're going to say, I know exactly the Vikings. Cool. What's the next standard? Do they have 140? I doubt that they have 140. 150? Any disagreement? 150. So they don't have, they can charge you an arm and leg and a nose for 140, but 150 is good enough. If it's not a standard, what do you guys do? Go up. How many poles this circuit breaker is going to be? 2 poles. 2-pole circuit breaker.
That's saying 240.6.
240 dot, this one? 240.6, yes. Thank you. 240.6. Any question, guys? Brian, my friend, here's your A. You're looking at your A, man.
He's looking at C.
Go ahead, Brian.
What was the 137 point? Yeah.
137.5 is the full load current. Did we do something?
Times 2.5.
Oh, yeah, times 2.5. Yeah,
Okay.
this one. Yeah, I thought I did it. Yeah, this is the 55 multiplied by 2.5. Any questions, any comments, Joe, my friend? You guys should be in a good mood. The Viking won last night. And
Monday.
good.
It's Monday.
It's Monday. Monday's just 5 days to Friday, or was it 5 days to Saturday? Okay, may I go to the next page? Can I have your authorization to go to the next page? All right. Let's go to, okay, we got this one, we got these. Okay, disconnects. Now, here's the reference for you, 430.11.110, right? Everybody knows that, that's your reference. If you go there, it will tell you multiply 1.15 by 55. What's the 55? The full load current that we have. So 1.15 times 55, the full load current for the motor. I need 2 gentlemen to agree on one answer. Where are my calculators?
63.25.
Second?
Yep.
63.25.3. Good enough? Okay, 63.3. Then your 63.3 amps, you take it to DeWalt 3-12. DeWalt 3-12. Right? That's where you get your disconnect. And what size disconnect? They go 30, 60. If you go there, 100. If you guys don't have DeWalt in the test, you can borrow it. All what you need is just one page, really. We're going to be using a lot, so you can borrow that page. Anybody knows what the answer here? 100 amp? We're looking at 100 amp disconnect. Non-fused. Why non-fused? Did you hear them saying fuse it? This is just dummy thing to shut down safely the system. That's easy. Any comments, guys? Any questions? Disconnects? Shall we do the controller? If you guys go to the controller, it says 480.83 tells you very simple. Controllers have to be rated for the horsepower and the voltage, 120 volt, and the phases, single phase.
I thought it was 208.
Did you write 120? 208. You're right. It's hard for us to think like you. Think of 208 as single phase. 208. DeWalt 6-4, single phase, 6-4. Uh, 6-4 under 208, single phase. What's the controller? We need a horsepower of 10. If you guys go all the way, is it 2? Anybody disagree that's 2? Oh, this is 3 phase. No, single phase that will be 3. You're going to go to 240. Why 240, guys? 220, 240? Because it's 208 system. So everybody can see that NEMA 3 is your baby. NEMA 3 from the DeWalt. If it's 208, you go to the next standard voltage. In this case, 230, 240. So this will be NEMA 3. NEMA 3.
We need to have the NEMA size for the controller size?
Yes. And DeWalt 6-, you can go to voltage 208. Remember, it's 208 voltage in this. And because there is no 208, we went to which voltage we went to? We went to 240. We went to 240, the next standard. Remember, it says also single phase. Write yourself a note when you use this table. 208, 240, go to 240, single phase. That's where you go. Because otherwise, there are multiple of them. You need to know which voltage and what phase. Cool? All right. Let me know when you guys are ready. Okay. Overload. Overload, unless I tell you, if you guys go to 430.32, 430.32, when you find the overload for the system, what's the nameplate? You have to have the nameplate current. Unless I give you the nameplate current, and you know the nameplate current. Right now, do you know what the nameplate current is? On the test, what you gonna do for me? Do you see it on this sheet? Okay, so what are you gonna do? You're gonna sit and cry and yell and chat, or you use the NEC code book if you don't have it. Okay? In this case, I want to be giving it to you now. If I'm not here on the test, you might not get it. So what are you going to do on the test? If you don't have the nameplate full load current, use the code. So I'm going to tell you that this one given 50, what was it, 55, 50 amps. And I'm going to say here given. If you have to guess on these, they usually, I would say 10% lower than what the code tells you. 10% lower. If you have to guess sometimes, 10% lower than what the code gives you. This is given. Okay, so here's my 50. Who's my favorite?
Wasn't it 55?
It's 55, the NEC code book, but I'm telling you that I went to the nameplate for this example and I read right into it 50. That's what I'm giving it to you.
If it's not given, we go to that table.
Yes, if it's not given, I already gave you 50. If it's not given, you use 55. Very good point. Almost always 99% of the time it's given, guys. So what's the answer? 57 point. What did we do?
It was 57.5.
0.5. Okay, two gentlemen will never disagree on, agree on the wrong answer. That's it. Equipment grounding conductor, guys. What's the overcome protection device? That's the overload. For equipment grounding conductor, what's the well, slow down, Chad. So that's the overload. So, Zach, tomorrow, if I'm not here, so you guys, when you do it, there's no nameplate. What are you going to do for Chad? Thank you. Everybody got that one? I don't want you to be yelling at Chad.
For the test, are you gonna do the given?
You read the example. If you see the given, you use it. If you don't see the given, yeah. Okay, so 57. Then, equipment grounding conductor, they're always based on overcome protection device. What was the overcome protection device, guys? The overcome protection device was 150 amp overcurrent protection device size. Oops, actually you put it right here. So overcome protection device is 150 amps. You take this one to 250.122. Anybody can tell me what the answer is? One conductor, number 6, AWG, NMB cable. We're not alone here. We're in a cable. Anybody second, my friend? Do I see a second? You guys run at 50 hertz or 60 hertz?
Number 6.
Number 6? Okay, 42. The higher the hertz, Aaron, my friend, the more the speed goes. That's it. Now, how hard would it, Andrew, my friend, to ace that boy? What you're going to see tomorrow, literally, same thing, different voltages or different horsepower. Okay? It doesn't hurt my feeling, guys, to write yourself a cheat sheet and put it on the side, and that's how we calculate this, how we calculate that. I don't only see the examples, though. Cool? This will be PDF if you missed a step or... You guys are designers, you have all the material in front of you. Here's the steps, do it. Okay. Brian, my friend, let me know when we're good, thank you. Okay, example number 2. There you go, should have gone to. Example number 2, guys. This is B. In your sheet, this is B. Okay? This is equivalent to B. Everybody got that one on your sheet that you have? B. B is a feeder powers an 8 kilowatt 240 water heater and another 3 kilowatt 240 water heater. The power system is 240 120 single phase. The wiring methods in NMB. Find the following. Right? I'm reading from that sheet. All what I need you to do, guys, is find it for the 8 kW. I care less about the second one. I just want the 8 kW information. Here's my 8 kW 240 single phase. The system is 240 120. We need to size first the conductor, second overcome protection device, third the disconnect, fourth the equivalent grounding conductor. 4 things for this boy. 4 things for this boy. Can I move on when you guys are ready?
What's that? That's simple one. Oh, single phase.
Single phase. Single phase, yeah. You don't like my single? I'm gonna go close it for you, Mike. So there we go. Oh, you didn't have a sheet? I'm sorry. You have that one, didn't you?
Chapter 1.
Oh, oh, sorry, man. I knew I goofed up with something. Okay. Okay. I'll take this one away. Any question guys about that before we move into the next? All right, brand circuits. It's a water heater. I have my. Okay, it's a water heater. I want to grab this one because it's not here. Okay, so let's go for what was it? Was it a water heater or a furnace? Water heater. So for water heaters, guys, there are appliances. This is just to tell you they need an individual circuit, and so these are their appliances. They need individual circuit. Okay, let's go do the calculation. Here's the math that you're going to do for this board. What was the kW in that board? 8. So you take the 8. This is my green. Take the 8. Don't forget it's 1,000 divided by what's the voltage? 240. Give me the amp, will you?
33.3.
How much?
33.3.
3.3. Thank you, sir. It's just it goes the age. They don't work as good with age. Any second? Thank you. All right, so let's go multiply that. Then we multiply it by 1.25 because continuous load, right? It's a water heater, continuous load. So that will give me what?
41.7.
41.7 amps. Any second?
Yeah.
Second, yeah. From 422.10a, guys, will tell you you have to have the appliances in a second here. So take the 41.7 amp to 310.15 B16 under 60-degree column. Anybody knows what 60-degree column? We're using an NM cable. Number 8? Number 8 or number 6? I go for 8. 6. Under 60 degree. Second. So this will be number 6. How many conductors? 6, 2, A, W, G, and M, B cable. 6, 2. Do I see a second here?
Nope.
6, 2. Okay.
What do you say that table 422 is for there? That's the 41.7.
422 will tell you that you have to size, it's continuous load and you have to size overcome protection device too based on, you're going to see how we size overcome protection device in a second. So number 6 is 55. You guys are good. Okay. Can I go to this next? The size overcome protection device? Okay. There's your. This is where brand circuit 422.10a individual circuit 1.25. That's what this tells you. I just told you then. Okay. Overcome protection device. Do you guys remember overcome protection device? Because these are appliances. We multiply by 1.5. Anybody remember the table 422? For appliances, we multiply 422.10a 422.10a. So you multiply by 1.25. So what was the full load amp here, guys? What was the full load amp?
41.7 or 33.3?
No, just the full load amp that we calculated. 33.3 multiplied by 1.5. Any, how much? 50 even? 50 amp even? Okay. So you take the 50 and you try to find the standard overcome protection device. Is 50 a standard? Yeah, we hit the jackpot, 50. So if it's not a standard, you can go up, by the way. So it's a 50. All right, so we're done. Here's where we do the check. Remember how we do the check, guys? Any question about 1.50 to 4220? 422.10a.
You're gonna, 430.52 to get that, the size for that.
The 1.5. It's coming from 422.10a, I believe.
No, where you're looking for the standard size, OCD.
Oh. 240.6.
Oh, I didn't even.
240, that's here, 240.6, 50 amps. Now here's the check that you need to do. You need to do the following check. I have, what is it, 30, here's my 33.3 amps. My overcam protection device was 50. My conductor size was number, what did we say, 6.2? Number 6.2. Now the only thing I want to check, can number 50 protect 6.2 under 60-degree column? How much current number 6 can get you?
55.
Number 6 from 310.15 B16 under 60-degree column, how 55 amps. So I want you to watch this. So I have a 50 amp protecting a 6.2 that feeds a 33.3 amp water heater. Up to this point, you're done. There's one little check you're going to do. Here's number 6. Can number 6, how much current can number 6 carry? 55. And I'm breaking it at what? 50. Is this cool?
Yeah.
Had this number be 40, what do you need to do? Up the conductor to the next standard. This is the check that we do at the end. Remember how we did that? So are we good? Yep. I have a conductor that can pump 55 amps. If it was 40,
Or you have to go to number 8.
2 options. Either you can go to number 8 will give you this amps. You're going to go to next, next standard up. You're going to go to number 4, or you're going to lower the full load current here into what? 40. Does that make sense? The calculation that we do?
In 422.10a, is
Yep.
this 125% of the market rating? Why are we using one?
I think that's why I think it's 422 for appliances. You guys have a that's what I wasn't sure if it was the right reference for it. It's an appliance 4022.10. No, I know, but there's one 4022. Let me just.
E for the single non-motor
Yes.
operated.
What would that be?
422.E or 422. What is that?
E. 422.
11E.
422.11e. Yes. Thank you. 422.11e. 422.11e. That's for the overcam protection device. That's what this can to be. As an appliance. Cool?
Yep.
Thank you. The other one is dedicated circuit, just to give you a dedicated circuit, 1.25. Okay, disconnect. For the disconnect, I'm going to use the 33.3 times 1.25. We did this math. What was it? 41.7 amps. You take the 41.7 amps and you to the volt, that will give you 60 amp 2-pole non-fused disconnect. Granted, your circuit breaker can act as a disconnect for your water heater too, if it's within sight. Cool? 1.25. Equipment grounding conductor, you take the 50, remember that 50 amp overcam protection device, the 250.6 is 122, anybody can tell me? The overcam protection device, 250.122, what size would you get? How about if we use a calculator, huh? So here's a 50
Number 10.
amp. I have number 10. Number 10. How many? 1, number 10 AWG in NMB cable. We're using an NMB wiring method, it's the most. That's it. Now how hard that would be to get an A tomorrow, Joe, my friend. Adam.
Joe.
Joe will get an A. How about Adam? Adam will get an A.
You know you don't get A's, Joe. You get A pluses. No, you don't.
All right, let me know when I go to the next example. Can I grab that one for a second here in front of me? Yeah. Okay, looking at your sheet, guys, we finished A and B in your sheet. We're going to go to number 3. Number 3 is equivalent to E. A, B, C, no, equivalent to C. Everybody's on your sheet that I gave you. Number 3 is equivalent to problem C. Carrie, my friend, see that one? Okay. All right, everybody's aware of that one? So this problem, we're having full load amp 95. This is a furnace, an electric furnace. We're having a Mr. Electric furnace here, and we need to size the following for the furnace, electric furnace. It's a 240, 95 amp full load current, single phase system. We need to size the conductor, the disconnect, the equipment ground conductor, and the overcurrent protection device. The same 4 things, guys. Piece of cake. Let me know when I can move on. You guys have the details in your sheet. What we need to size is these 4 things. Okay. The first thing you need to do is a 95. So the full load amp, it's branch circuit 422, continuous load 122.10A, and a heater and a bunch of others. So that will give you 95 amps. Multiplied by 90. Why did we multiply 1.25 continuous load? What do you guys get when you multiply 1.25 by 95? 2 gentlemen agree on an answer?
118.75.
118.75, 118.75.8 amps. Do I have a second? Okay. Then you're going to take the 118.8 amp and go find yourself a conductor under 6. Now I don't know if we can have enough conductor on them size that can get it. Just assume we have. How much? Oh, we didn't make 1. So that will be 1. Any second?
Yep.
Good. I have a second. So how many conductors though? It's water heater 2. So number 1/2. So number 1, 2, A, W, G, T, 1 aught. Oh, I don't know if they make 1 aught. Let's assume they make 1 aught. I don't think they make 1 aught. They go down to 2. But for the sake of the calculation, let's assume they're making it. So it's going to be number 1 aught, number 1 aught. That's why it becomes 2. So 2 conductors, number 1 aught, NMB cable, and I'm going to put question mark here because they don't make it. I think the largest that they can do is number 2 on that cable. So if you are faced in a situation like this, what would you really do? MC cable. Use an MC cable. That's all.
Is there a reason why you raised 310.15 there?
Yeah, because it's a heater,
Oh,
and the heater tells you 1.25.
okay.
It's an appliance and it's a heater, so a bunch of things apply to it. Between all the heater and appliance, you multiply by 1.25. Where's that 1.25? Cool?
So we need to go down to 334.80 to size it.
This will give you when you go there, this will give you go to 60. You still need to go to table 310.15b16. We'll erase that one. Did you erase that one? 310.15b16. This is going to be like Viking to you guys. 310.15b16, the same thing, right?
So what's the 424?
424.3b, this is, it tells you heating equipment are sized based on continuous load 1.25. Cool. Now, disclaimer, tomorrow for the test, please show your work. Okay, if you need another sheet of paper to attach it to, please show your work. I don't want to see just an answer, guys. Please attach your work. If your answer is wrong and you showed me your work, you will get at least 60% credit for it. If your answer is wrong and there's no work, you get 0.
So that 125 to 1.25 is non-continuous
It's continuous.
or non-continuous?
1. Should we go 2? Go to 2. Okay. Same thing. From 424.3b, I size this one because it's a heating element, guys. A furnace, I typically use 424.3b. It tells you size it a continuous load heating element 1.25. Right, 270. So what was the full load curve for that boy again? 95, 95. And we did this one, 118.8, right, amps. So 118.8 amps, 240.6, what would give you? 125? I don't think there's 120. 125 amp. I have 2-pole circuit breaker, 125 amp. This is what you're going to do with your check, 95 amp, 125 amp. What was the conductor size? It's 1 aught, right? Number 1 aught 2 that we did. So go to number 1 aught, number 1 aught, 310.15b16, 6-degree column. How much current that 1 aught can give you on the 6-degree column? 125 even?
Yeah.
Wow, even. Okay, now, am I okay in this case? This one, check. This is for your check. You don't have to do that one. Check if number 1 aught is actually protected. Is it protected? Yep. Move on. Okay, disconnect. Same way, 95, 95 amp, 118.8 amp, 118.8 amps, 312 DeWalt, I think it's 200 here. Anybody can check? Your disconnect is going to be 200 amp. Did you verify it? 200? 200 amp. Piece of cake. Equipment grounding conductor, guys, 125 amp for equipment grounding conductor. The overcap protection device is 125 amp. 250.122, the conductor would be number 6. Thank you. So it would be one conductor, number 6, AWG. Inside an MB cable, if we can, I'm going to put question mark here, because I don't think there's an MB cable that can carry it. One more time. The disconnect the same way, guys, exactly. The overcap protection device, the disconnect and the conductor, same calculation. We go to different table though. Equipment grounding conductor, 250.122. Yes, sir. Okay.
Over tomorrow's test, are we just gonna assume it's all and then don't have to think what
What does it say on the sheet? Did you see the sheet? It tells you they're all an MB. I will tell you it is an MB.
even if it's question mark like this one?
The reason why I put question mark here, because they don't, I confuse with the question, because they don't make NMB 1 aught.
That's what I'm saying, if there are any of the questions like that.
They're all NMB. Oh, you don't have to. If I say NMB, just write NMB. Size it based on 6-degree column. Okay. What's question number? Can I sneak that one from you? Thank you. I'll grab that one. Thanks. So this is. I'm gonna give you guys 5 minutes break, right? Stretch a little bit, and then we're gonna jump into 2 more, and then we're done. Cool? 5 minutes break, two more, and then we're done. So this is what we're gonna be doing here next.
So, you're always down for that number, so for this, so you carry that over.
Solutions, Chad. Okay. Let me steal your sheet here one more time. Okay, question number 4, Andrew, my friend, is equivalent to D. On your sheet, can I have thumbs up, Chad? We know 4 is D. D says I have 2 air conditioning, and I need to feed them with a feeder, and I'm only interested in sizing the branch circuits for one of them. 2 air conditioning, and I'm feeding them from a panel, and I'm only interested in what? In finding the branch circuits. Cool? I'm only interested in finding the branch circuits. The wiring method is the most disgusting wiring method, which is NMB still. We're still doing residential. Starting Monday morning, you would never hear Chad talk about NMB again. Romex, right? MC boys, we're MC boys. Right? I should bring a couple of, because Aaron, you didn't do any wiring with us. I'll grab samples of MC and all this stuff for you guys, but the rest of you probably have seen it. Okay, so rated RLC is rated load current. That's the one right on the nameplate. Says 41 amps. That the voltage is 240 volt. It's circuit breaker. I need to find the following: the conductor, the branch circuits, the overconduction device, the disconnect, and the equipment grounding conductor. The same 4 that we have been finding for a while. Can you have thumbs up, Chad? We fully understand. We're doing the same problem except for what now? NAC. Can you guys see how we're doing? These are different type of loads you're going to encounter. Okay? It's Article 440 is our deal. I'm going to go start with the calculation. Okay. So what was the amp for? So the first thing you need to do, what was the amp? 42, right? 41 amp. From one page to another, I increased it by 1. So 41 amps. Who is my favorite A through C student who is going to do? Give me the math for that. Second, 51.25.3. Is that good enough for you? 51.3. Okay. Then you're going to take the 51.3 amps. Remember why we go to the 60-degree column? Anybody remember that? Because we're using the NMB cable. That will give me number 6. Number 6? Because 6 was good for 55. So this will be number 6 slash how many? Air conditioning? 2 AWG T N M NMB cable. NMB. That's it. Where do I know that I have to multiply it by 1.25? 440.32. Guys, Kerry, here's advice for you. When you guys start sizing for, if you don't know and you need to size that cable, if you don't know anything about the load, 1.25. You default to 1.25 for cables all the time. That's your default for feeders and branch circuits. Okay, the same thing, overconduction device. Overconduction device, Brian, my friend, 1.75. This is not from my basement. This is directly from 440.22a. It tells you multiply the overconduction device because of the air rush and because of the special characteristics and operation mechanism of the HVAC equipment, the heating cooling, multiply by 1.25 to account for the air rush and all and so forth. So that will give me 41. Who's my favorite gentleman who's going to give me the answer? 1.75.
71.8.
Second? 71.8. Did they hear a second?
Yeah.
Yep, thank you. All right, why did we multiply by 1.75, not 1 point, not 2.5, not all these multipliers there? Kerry, these multipliers have a tendency of making you nuts. So for the test, what do? Cheat sheet. There is no on air. This is my cheat sheet that I use here. No way on air. I can personally, and I've been 23 years in the field, I remember all this multiplier for all of them. Cheat sheet. You're not expected to memorize them. There's just so much. Cheat sheet. Cool? Everybody's okay with this? Aaron, my friend? Cool. All right, so 71.8 amps. Either you custom design yourself a 71 amp, or you have to go down. Why go down, not up? Why do you go down, not up? Same thing. 440.22a tells you it doesn't say anything about going up. If it doesn't say anything about going up, what's your options? Stay where you are, which means custom design a circuit breaker for you, 71.8, which they can make for you, no problem. Or what do you need to do? Go down. So what would that go? 70. How many poles? 2 poles. 70 amp, 2 poles circuit breaker. Let me know when I can move on.
Why do you go down instead of up?
Because if you go 440.22a, if you read it, it says you multiply maximum over computation device shall be 175% of the full load current. Maximum. And it doesn't say what happens if you don't hit the standard. Doesn't say anything. So if it doesn't
That's that other part that says you can go not to exceed 225.
now, if it doesn't work, you size it, you install it, and it doesn't work, then you go up. But we didn't size it, we didn't try it yet. Default 175. I used to default 225, but default 175. Guys, the default, the lower the overcomputation device, the safer your system is. Everybody knows that. The lower, the safer. Okay, disconnect. For disconnects, 440.12a1, it will tell you 1.15. Who asked me about that one? Why 1.5, Chad? One time and 1.25. Right here, 1.15. Not from my basement, right? From 440.12a1. Cool? Okay, so that multiplied by 41. Was it 41? 41, what would that give you, Jamie, my friend? 47.15.2 amps. Any second on Jamie's answer?
Yep.
Thank you. So then you take the 47.2 amps, take it to DeWalt 312, page 312, and that will get you 60. 60 amp, 2 pole, non-fused, 60 amp, 2 pole, non-fused. Okay, the overcomputation device always sized based on what? The equivalent grounding conductor is always sized based on the overcomputation device. What was my overcomputation device? 70 amp, 250.122 give you what?
One number 8.
One conductor, number 8, AWG in an MB cable. Now here's my question for you. That's a minimum. Now what if you went to the number one? We remember the size that we use is number 6, right? What if the overcomputation? What if number 6 cable has number 6 equivalent grounding conductor? It's better, right? That's your minimum. I can't emphasize. That's your minimum. Okay. Here's another A, Brian. Okay, so they asked. Oops, excuse me. I should have I printed myself one. It was the wrong one. Okay. The last question on the test. The last question on your test would be residential calculation. I hope that will review what you guys are doing. We're doing a lot of calculation, residential calculation. Any question about the HVAC equipment? lump sum them. By the way, our final, guys, the final that we're going to do on Friday, is going to be identical to this. I'm going to grab certain things from the two tests that we did and make them your final. Because these are the most important calculation part of this quarter is what I'm putting on the board. You know them, you're good, we move you on. Okay, now here's, this is question D, is that D? In your E. This is E on your sheet. E, 5 on mine, E on yours, 5 on mine. That's exactly what you guys are gonna do for me today for the project. It's residential calculation, load calculation. Let's just go over what the requirement first. Can you guys compare it to what you have? I have calculation units on number 10. So tomorrow on the test, yours instead of 10 would be 25, for example. Would it make a difference? No. I have a residential load calculation for a building. This is a big building. All right, sir. So how many 10 of them? Here's 2, 1, 2, 3, 1, 2, 3. Is it 1, 2, 3, 4, 5? 5 times 2. Here's my building, right? 10 units in it, both sides. And I need to I'm bringing a service to this building. That's what we're doing, to feed this apartment building, right? 10 units in it. Okay, each unit is 4,100 square foot. The voltage is 24120. It could be 28120, 24120. AC, each unit has a 42 amp rated load amps AC unit at 240. Each unit. Heating, each unit have heaters, baseboard heaters or furnace heaters, electric heaters, 8 kW at 240. Each unit has a 19 kW range. Each unit has a number 6 kW dryer. Each unit has a garbage disposal of 2K. And each unit has a dishwasher of 1K and a water heater of 7K, 240. And because the apartment is in Minnesota, we have a lot of water. We need a sump pump in the basement, right? So we put one sump pump, 5 horsepower, one sump pump in the basement at 240. And what's our job? Our job, guys, is to size the service to this building. Is that realistic for what we do? Right? You guys are designers. That's Kerry, what, I don't know what how many stories is the apartment that you guys are working on? Yeah.
6 stories, 47.
Yeah, 6 stories, 47 units. Exactly the same calculation. You know, there might be other loads, an elevator and blah, 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 but you add it. That comes in the commercial. What's the voltage system, 28120 or 3-phase or 24120? 3-phase, 28120. Typical, when you go to apartments, guys, typical they start using 28120 3-phase. And the calculation, by the way, doesn't change. They only divide by 2.8 and the multiplier, and we will do this one in a commercial project. Okay. All right. So what do I need to do? I need to walk you guys through the sheet that I have in front of you, asking you about 11 things, 11 major things. These are the 11 major things that you need to do. One of them is building demand load for lighting, small appliances, and laundry. That's, you're going to see it in a second here. The demand. When I say the demand, guys, meaning after you apply all these factors, that's a number that I'm looking for. And I'm going to be putting numbers next to them as we go. Okay, the first thing for this building, step by step, is 220.12 give you general lights and receptacles, right? From the table, I don't know if I have the table here. Do I have the table here? I don't think I have the table here. Okay, before we go, this is what we have, guys. We need to find the following. We need to find, in my example, we need to find the service, the overcome protection device, and the conductors, and the equipment conductor. I don't think I'm asking you for the main bundle jumper, am I? Service entrance panel, overcome protection device, building ungrounded service entrance conductor, building grounded. You know, I'm only asking you in the test about the ungrounded, the grounded, and the service and overcome protection device. I'm not asking about the main bonding jumper. These 4 things, basically. Cool? All right, so let's go back and start. From this table, since we're doing dwelling, guys, It's going to be 3 times, what's the square foot of the building? 4,100. 41, right? 4,100. The building that we have, is it 4,100? Yeah. So I need somebody to help me with the math, please.
10 units, 4,100 square.
Times 10. Thank you. There's a 10 too. So 3 times 10, because why 10? There's 10 of them. I'm doing it for the whole building, remember. Any question? What's the answer?
123 kW.
123 kVA. Is that second? Can I have a second on that?
Yep.
Second. Cool. All right, small appliances. Brand circuit. Each apartment's going to have how many small appliances? 2. 2 for each apartment. Multiplied. How many apartments we have? 10. That will give me what? 2. No, times each. Let's do it this way. 2 circuits. Each circuit is 1.5 kW, kVA, multiplied by how many of them do I have? 10. So that will give me 330. Is that 30? Can somebody verify that this is 30? 1.25 times 2, 3 times 10, 30 kVA, right? Why 2? 2 small appliances for every apartment. Why 1.5? Each one of these small appliances is 1500 volt amp from 220 to 52.8. Why 10? Because I have 10 apartments. Can I have thumbs up, Chad, before they understand? Now tomorrow, same calculation, different number of units. Okay, laundry. What's the laundry allowance? 1 circuit, multiply it by 1.5 kVA multiplied by what? 10. So that will give me what? 15 kVA. Am I right here? 15 kVA for this step. Now, Aaron, my friend, have a cheat sheet for you that tells you to do that. Because you're not going to be able to organize your mind like this. I mean, there's no way. You're going to get confused. By the time you finish the motors and you go here, you're going to get confused. That's why we have a cheat sheet, guys. Let me know when I can move on. Okay? Good. I'm watching everybody else too. Brian?
Yeah,
Good. Thank you. Okay, now this is when we add them all up. I want you guys to give me the general light. What was the size that we came up with? I know this is 30K.
123.
This is 15K, and that was what was the first one?
123.
123K. Add them up. So this is 50, 60, 168. 168 kVA. Add them up. Okay, cool. That's piece of cake. That's piece of cake. Now, demand. Now, this is where we're going to demand them. You guys remember how the demand from table 220.43? Then I'm going to take 168K and I need to apply the demand on them. Okay, so let's apply the demand. The first demand, the first 3K, leave them alone. I want to put them right here. The first 3K, leave him alone, right? Is this more than 120? Yep. Then the second 117K, what do you do with them? You multiply them by 0.35. Is it 35? You have to remind me here.
Yeah.
35. Okay, then what's the remainder? Then 168 minus 120.
So it's 48 kVA times 0.25.
Multiply this one by 0.25. And then add everything up. Let me repeat myself. The first 3K, leave him alone. Anything, the second set of 117, cut them by 0.35. Then anything higher than 120, cut them by 0.25. Everybody understand what I'm doing here? These are almost stays the same. The first 3 and the first 17 almost always stay the same, 99% of the time. If you're more than 120, Jeff, The first two steps are identical for every problem that you have. The last step is different. Then you take 168 minus 120. I don't know if I want you guys to, I want to highlight these in black here. This stays the same, this stays the same, and this stays the same. In any problem that I give you, these three things that I highlighted are the same. The only thing that's going to be different is what? This number. Cool? Especially if you're higher than 117. If you're higher than 120. If you're higher than 120, these are the steps that you do. Okay, can two people do the calculation? Give it to me, please.
55.
0.95.
55, 55.95,
Yeah.
56. 56 kVA. Do I have a second? Did you calculate it? Love it. Thank you. Now I'm going to highlight what stars right here next to it. That's what I'm going to carry. Now, carry, my friend, question number 1 that says building demand load for lighting, small appliances, and laundry. That's the answer that I'm looking for. Everybody get that? That's number 1 answer that I'm looking for. Can I have thumbs up, Chad? When it says building demand load for lights, receptacle, laundry, and blah, 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 that's the answer that I'm looking for. That's number 1. Cool? Number 1. 56. And I highlighted it because I'm going to carry it downstream. Okay, let me know when I can move to the next step. Yep, okay. Next, not this, next, range. Okay, let's look at the ranges. Do I have the table for the ranges? Okay, here's my table for ranges. Okay, let's see how many ranges. First of all, how many ranges do I have? What's the size? 19? Is it 19? kW. And how many of them? 10, right? 19 kW, 10 of them under C. What would that give you? 10 under C. Okay, I have 10 of them under C, 25. Everybody got 25? 10 of them under C, 25. Okay, no problem, Chad. So I have 25. The first thing is 25 kW. Okay, that's step 1. Then you guys remember every kW more than 12, I have to increase the demand by 5%. So here's how we do it. So then I take the 19 kW minus 12 kW. 12, this 12 is from the table. That will give me what? 7 kW. Then you take the 7 kW and you multiply it by 5%, and that will get you an increase of 35, right? Right? 35% increase. 5 times 7 is 35. Never changed since the Greek days. 7 times 5, 35. Everybody knows what I did? Just subtract them. Then the last step is the most important one. Then you take 1.35 and you slam that thing against that 25 kW that you have, and that will be the demand load for the whole steps. Anybody? What's the answer?
33.75.
33.75, 33.8 kW. Now you highlight this, you put stars next to it from both sides, and this is what I'm asking you guys for step number 2, for question number 2, building demand load for ranges. Cool? Why 12? Because if you go to note number, was it 1? Well, note number 1. Note number 1, it will tell you. I should write note number 1 here too. So this is also note number 1, table 2, 20.55. Cool? The ranges. Sorry, man. Yeah, it just tells you if you are higher than 12, anything higher than 12, 5% extra for every 1 kW. Okay, moving on to next step. Yes, sir.
Where'd the 25 come from? I'm sorry.
The 25 is from this table under C for 10. 10
Oh,
ranges
right.
under C. Yeah. Okay, so this is where we got that one. Dryer. Okay, let's go to dryers. What was the size of the dryer that I gave you guys? Can anybody go back to that thing? Was it 6K kVA? Okay, I have 6 kVA. And how many of them do I have? 10. Okay, what's the derating factor that I have for 6 kVA at 225? Actually, this is 10. This is number of dryers should be. Number of a dryer is 10. Well, let's do 6 kVA for 10 of them. What's my multiplier here? The derating factor for 10?
50%.
I think I have it here. Did I? No, I don't. Okay, 50%. So my derating factor is 50%. Then, piece of cake. I'm going to have 6 kW, kVA, multiply it by 10. Anybody knows why 10? 10 units. Multiply it by 0.5. Anybody knows why 0.5? Because the derating factor is 0.5. So that will be 30. 30 kVA. Highlight it, put stars next to it, and that will be number 3 in your sheet. Number 3 in your sheet. Any question, guys, about that? Number 3 on your sheet. Shall we move to number 4? Will you guys have a chance? Or number 9 in our case. Everybody knows where the 50 came to be? 10 of them. Now here's my question for you, Andrew, my friend. If your dryer is less than 5, you always use 5 on this 5 or higher. Cool. So tomorrow, if I give you a 4 kVA dryer, what do you need to do with the dryer? 4 kVA. Up it to what? To 5. I might be that mean and put you a 3 kVA dryer. You have to up it to 5. That's especially for the dryers from 220.54. The article tells you so. Not Chad. I'm just the delivery man. Okay, heat. Let's look at the heat. For the heat, what was the size of the heaters? Was it 8? I gave you guys? 8. Okay, so I have 8 kW multiplied by how many of them? 10. That will give me 80 kW, which is equivalent to kVA because it's a resistive load. The second one, guys, is what was the size of, did I give you the AC? What was the AC? 42. So you take the 42 amps, multiply it by 240. That's the size of one AC. And since I have 10 of them, what do? You multiply them by 10, right? And since you need to convert all this junk into kVA, you divide by 1,000. Repeat. 42 times 240 give me the kVA, the volt amp for the 1 unit, multiplied by 10, all the units, divide by 1,000 because my answer has always been in 1,000. We're doing, let me just get rid of the 1,000 here because, is it confusing you, the 1,000 here? No? Okay. So what would the answer be?
100.8 kW.
108.
100.8 kW.
100.8 kVA. In this case, kVA. Anybody disagree with that? Young fella? Second? Second. Okay, then we have to choose the largest. Choose the largest of the two. Which one is the largest? Do I need the... Is 100 more than 80? Low, Chad. 100.8 kVA is the step that you're going to take and you're going to highlight. And that will be in your example for, this is number 4. The answer, demand for number 4. That's your demand for number 4. Can I have a thumbs up, Chad? We understand that one? Almost there. Okay. Let me know when I can go to the next step. We did the heat cool. Fastened in place. Fastened in place appliances. Cool. Okay. Fastened in place appliances. Can somebody give me the dishwasher size?
1 kVA.
1 kVA times how many? 10. How about the garbage disposal?
2 kVA.
2 kVA times 10. How about the water heater?
7 kVA.
7 kVA times 10. Add them up. So this will be 10, 10, 100. Right? 7 times, that will be 100 kVA. Can I have a second? 100 kVA, right? So 7 times plus 3 times 10, 100, right? If you do the math on them. Then demand. What was the demand for these?
100%.
The demand for fasten in place appliances, my friend, is 0.75. 4 or more, 0.75. So I take the 100 kVA multiplied by demand of 0.75, and that's coming from 220.53. If anybody disagree, go to 220.53. If it's written there, it's golden, at least in front of the law. Okay, if you guys do that one, that will give me 75, right? That's easy math. 75 kVA, and now I highlight this and I put my stars next to it, and that will be the demand for step number 5. Thank you. Step number 5. Why 75%, and where did it come from, Joe? 220.53. 4 or more? Is it 4 or more? Yeah, 4 or more. You cut them by. Do I have 4? I only have 3, Chad. Times 10. You can't believe how many people they say, well, yes, there are 3. Times 10. That's why I have 30 appliances. Because they're all going to be seen by the service, right? Okay. Let me know when we can move on to the last step. I use this review, guys, also as a teaching experience. I hope you understand. I'm not wasting your time or mine. I use it as another refresher. So, okay, motors. How many motors do we have? 1 ton. And what was the size again? 5 horsepower. 5 horsepower. Okay, from 430 to 248 under 240. What's the 5 horsepower? What's the full load amp with that boy? For the 5 horsepower. 2 gentlemen agree?
28.
28. Anybody disagree with my friend? Everybody agrees with that? 28. Then, that's piece of cake. That's for my motor, right? Then, since it's a motor, we 1.25 continuous load, add 25% on largest motor, multiplied by 228 times 240. So I will take the volt amp of one motor, add 25% of it because it's like a feeder, we're sizing a feeder, plus all the other motors. Any other motors on it? Plus all other motors, 0. That will give me
35 amps.
altogether 35 or 28
28 times 1.25.
times 240 plus 0.
Why are we times it by 240?
Because we're adding volt amps. You can't add apples to oranges, right?
Oh, yeah, okay.
Yeah. The reason I had this question asked on my YouTube channel, say, Chad, why do you multiply the volt amp by 1.25? because we're adding volt amps. You can't add amps to volt amps. It's like adding chads to Zacks. You can't. Huh?
400.
84,
Divide immediately by kVA. Always by kVA.
8.4 kVA.
8.4 kVA. We always use kVA. So here's the step that you're going to take with you. So don't forget that this also will be divided by what? 1,000. Because we always use kVA. Volt amp is baby talk, right?
So what's the plus 0 here?
The plus 0,
Because there's no more other motors.
you got it. No more other motors. And that will be for step number 6. Now, 8, 9, 10, and 11 is sizing. 8, 9, 10, and 11 is sizing. Sizing the stuff. Let me know when I can move on.
You don't want to do a total demand load, or?
You're going to see in a second here. Okay, number 15. Do I have the total demand load? Yeah, number 7, yeah. Total building demand load. Can you just see how it matches number 7? Carrie, you see that 7 is this step here? Okay. Can somebody give me these, please? Starting from the first one, step. The light.
55.95 kVA.
Step number 6. The first,
56.
okay, this was 56 kVA. And this one, step number 7, range.
33.75 kVA.
33.7 kVA. Step number 8, dryer.
30 kVA.
30 kVA. How about step number 9? Heat.
100.8 kVA.
100.8 kVA. How about fasten in place?
75.
75 kVA. And the last step for the motor, what was it?
8.4.
8.4 kVA. I'm going to add them all up. Anybody anybody disagree with these numbers? I know we were doing some approximation when we were doing it. I need 2 gentlemen to add them all up.
304 kVA.
304
Yeah.
kVA. Anybody disagree? 304 kVA. This will be the answer for step number 7. Total demand load. Can you guys see that? Step number 7. The answer will be 304 kVA. Do they have seconds? Yep. Kerry, you did second, right? Okay. Now, 8, 9, 10, and 11 is sizing. Sizing the stuff. Up to this point, this is load calc. After that, that will start the sizing. The actual, this math, Zach, is mental exercise up to this point. Until you convert this one into wires and panels and overcome protection device, what you have done right now is I call it mental exercise. Right? Nobody's going to pay you because you said 304 kVA. Now what we're going to do with this, Chad, I need to go buy a panel, an overcome protection device, and a cable. Now, do you see how we went now into the real life? And we start converting this one to actual things. Okay, move on. All right, so 304, was it 304? Okay, so I need to take the 304, divide this, don't forget the K, divided by the voltage system is 240. Now, Zach, if the voltage system was 208, 123 phase, what do you do here? You divide by 208 times 1.73. It's the only difference at the end. But of course, we can't because the system is 240. What's the full load amp of this boy?
1,200.
1,200.
66.7.
67. Let's do that. 67. At this time, 67 amp. Second?
Yep.
Do I have a second? Thank you. So 1,267 amps. 1,267 amps. Cool? All right, panel size. To find the panel size, guys, I need to take the 1,267 to DeWalt 3-13. Make sure you go under single phase. Is it 2,500? No, 1,600? 1600? Can I have a second? from DeWalt, 3-13. Under single phase, don't forget it's single phase equipment. I have 1200.
1600.
What am I looking at?
16.
12, 1600. Everybody got 1600? So I 12, 1600. Okay, so this is 1600. This is my 1600 amp. I want to buy a 1600 amp switchboard, single phase. That's, Aaron, that's when it becomes goofy to use single phase for this size. That's why 3-phase becomes a big deal. It's not a good idea to get into a thousands of amp single phase, guys. Too much on the feeder single phase. Too much unbalance. So that's why they feed them with what? 3-phase. Okay. Then we're going to take the same number, guys. 1, 2, 6, 7. Now to 240.6. That's the main. What was the main for this boy? Is it 1600 too? I don't think they use
1200 or 1600.
1200, 16. So we 1600 again. Now this is where Kerry take this one calculation to your company, and they say, oh, I don't want you to think this way on the test. For 67 amps, I went to 1600. I could have dropped down to 1200 amp and save a lot of money. That's called value engineering. Later on, I want you to think, if you take this one to your boss and say, you know what, 67 amps, I know probably I'm oversized 25 here and there. I want to drop that 67 amps and size the whole system based on 1200 amp. As long as you write your name on it, registered engineer, and you're willing to go to court if something happened, it's okay. Does that make sense? I don't want you guys to think for the test, don't do that. For the test, we're going to follow the rules. You go up, but in real life, you're 67 amps higher, and you're going to go buy a bigger. That will cost you another probably 25% more money in installation. For what, 67 amps? I can eat them and go lower. That's a real life. Okay, so 1600, but we're not doing real life. We're doing it based on the book. So that would be 1600 amp. Cool? So I have a panel 1600 amp and a main 1600 amp. Then I need to carry now. Now, service entrance conductors, the 2 hots. I say match over protection device based on 240.4c. Match over protection device. So what was our protection device? 1600. Let's go parallel. How many sets you guys want to parallel?
3.
Oh, that's too much.
That's
Not
too
enough.
much.
Not enough. So what if I 4 times, if I divide by 4, give me 400. 4 sets. 4 sets, divide this by 4. So I'm going to do 4 sets. Why 4? Divide this by 4, give me what? 400 amp. 400 amp, I can carry it. The wiring methods. What now? Ooh, what did we do for wiring methods? Remember, we'll get screwed up with the wiring methods here. Are we using NM? You can't use NMB as service, so it has to be any other system. How did we do it last time? When we are we still using NMB cable here? You can't use NMB cable for a service. That's for sure. Did I use it last time? I used THHW. No, I use panels. For this one at last time, now this is service, bringing the power to the building. We're using, guys, you can't use an MB. So that will be conductors. So from here, that's what I thought. We're going to use table 310.15 B16 under 75 degree column. Celsius and 600?
Yep, 600.
600. How many?
4.
Service, I need 2 for 2 hots. So 2 conductors, number 400 KCM THHW. And how many sets?
4 sets.
Okay, so the way we're going to use it, we're going to say 4 sets. Here's the answer. The answer is 4 sets, 2 conductors, number 400 KCM, right? 4 sets. So Chad is going to go erase 1, 2, 3, 4, and erase the rest of them here, because that's 4 sets. That's from the example before. Okay. So here's my 4 sets. You guys any issues with that? Here's my 4 sets.
Wouldn't it be 600 KCM?
Yeah, why did you take it to 310.15?
310.15 B16 under 75-degree column.
But wouldn't it be a feeder, or?
These are service coming to the building. You cannot use an MB as a service conductor. So it has to be wire, and you can't find a conductor of 500 km anyway. So the service always sizes it based on this case based on 75. Oh, why didn't I use 310.15B, that little table? Because we're paralleling, guys. The actual service 1600, not 400. The actual service is 1600, not 400. We're paralleling. Okay.
Then why would it be 400 KC?
Wouldn't it be 600? 600
Oh.
KCM?
Who told me that? I'm sorry. Okay, this is whatever the table give you. Is it 600? Thank you. 600 KCM. Thank you. I see the confusion. Absolutely. Whatever 310.15 B16 give you. Thank you. Whatever 310.15 B16 give you, 600, 600. Yep, under 75. Good point. Okay, let me fly through the neutral, guys. Let me fly through the neutral. The last thing you need to calculate, so these will be, you already found the panel size, the overprotection device. Number 10 is the service conductor. You found them. The last one, number 11, is the neutral. So that will force you to do what? Neutral calculation. With neutral calculation, let me tell you what I'm going to do. I'm going to go back. Remember how we did it last time? We're going to go back into step number 1 and start doing the calculation from step number 1, right here. So for neutral, right here, you guys remember anything 240 will not count for the most part towards your neutral. So you start with right here, demand, so general light. So I'm going to start with the neutral, step number 6. Okay. Now, demand load, the neutral, this 56 will be the same. So neutral size, what I would like you guys to size like we did neutral. So the neutral, and for neutral, the same number, 56 kVA. Done. No derating, nothing. 56 kVA. Nothing. No change on that one. Cool? 56 kVA. Why? Because the small appliances circuit and light and laundry, they're 120. Can I have the thumbs up for this one, Chad? Okay, let's go to the range. Next, range. So for my range, you guys remember the range is, you cut the neutral by 70%. If you go to 220 or 61B, will tell you cut the neutral by 70%. So I'm going to say neutral. You're going to go here. You take the 33.8 multiplied by 0.7. Why 0.7? Because 220 to 61B gave me 0.7. So all that load would be 23.7. Highlight this, put stars next to it. Yes, because they carry neutral with it for control and other things. Yep. And if you don't believe me, 220-61B. Cool? Everybody got that one? We just cut it by 70% for the neutral.
Is it always by 70%?
Always by 70%. Always based on 220-61B. Cool? Can I move to the next step? All right, so let's go to next step. Next step for dryers. For dryers, guys, the same thing for dryers, 220-61B, right? So what do you get for dryers? And for neutral, you take the 30 and you cut it by 0.7. What would you get? 21 kVA. Carry it, star it, and that's what you're going to carry for the neutral. So can you guys see the rhythm, the pattern that we're doing? We're going back again and checking every step. Is it related to the neutral? Yes or no? If yes, how? Is it full or do I have to do it? If it's no, 0. Can you guys see what I'm doing? And this is typical. Your example tomorrow, your test is going to be identical when you do the neutral. Question about this? Fasten in place. Oh, the AC. These are all 240, guys. Do you think they're going to be anything connected? Nothing connected to them. So step for the neutral. You still have to put N, and you take it to what? Big fat 0. And that's what you're going to carry for it. The reason why I like to put 0, so it reminds me that there is no neutral for this step. There is no neutral for this step. Cool? That makes sense? No neutral for this step. Okay, let's go to fasten in place. Okay, fasten in place, guys. The first thing you need to do, this is 120, so this will continue to be the same. So this will be 1K times 10. This one will 2K times 10. This will be what? 0 times 10. Why 0? Because there's nothing connected to, this is 240. The Y here is 240, no neutral for it. Always. These are 120. Can you guys see that? Okay, then add them up. So that will give me 330, right? That will give me 30 kVA. Then don't forget that you have to bring the 30 here, 30 kVA, and cut them by 0.75. Apply the same demand rules. Anybody can give me the answer here, please? 0.75 of 30. What's 0.75? How much?
22.5.
22.5. Can I have a second? Repeat. You go to the appliance per appliance. Anything 240, drop it to 0. Anything 120, add it as is. And do the math here. Then come back and apply the demand factor. See how we apply the demand factor on the neutral too? That'll get you 22.5 kVA. Can I have thumbs up, Chad? Okay. You guys are going to tell me all these numbers when we go now. All right. So let's go to step number 12. Okay. Step number 12. Anybody can guess what was the neutral here? These are 240. Nothing. So neutral load is big fat 1. 0. Why? If I have one pump, that 120, you're going to add it. Everything is 240, right? Can you see it's 240 here? So what do you need to do? 0. That's easy, huh? All right, now let's go add them up. Who's my favorite student who's going to give me all these numbers so I can add them up? This one will be 56 kVA. Next one. The range. What was the range? 20. How much? 23.7 K. For dryers, 0. It was 0 for the motors. The dryers? What was the dryers? 21 K. For the heaters, big fat 0. For the fasten in place, 22.5 K. These are Ks. For the motors, big fat 0. Add them up.
123.2 K.
123.2 K. VA. Second, 123.2 K. Do I have a second?
That's right.
I'm sorry, Aaron.
Why does the range do it when you set 240 and the other one set 240?
Because the range, with the range, they take a neutral for certain control inside the range. Yeah, the others don't have a neutral. Now, how would you know? You just gonna have to know it. Like, there's a code article, like I showed to you guys, 220.61B. Yeah. Okay. Any question about these? See how easy that is to calculate the neutral? All right. So 123.2. Let's go back here. Now then, we need to size the neutral. Okay. So can you guys give me the neutral? That will be 1. Oops. I think we're going to do it this. We're going to find the amps here. Where did they? I don't have room to find the amps here, so I'm going to go all the way and find the neutral conductor here. So what was it? I want to find the I neutral. So that was 123.2 K divided by 240. Now, why would you divide the neutral by 240? They balance. You're balancing the 120 between the two hots. So what's the answer?
513.2.
5,
13.
5, 13 amps. Now, I have no choice. If I parallel the hots, what do I need to do to the neutral? Parallel them. Do I have a chance, even a chance to decide how many runs? No, I'm stuck with the 4. Why with the 4? Because the hots are 4. So piece of cake, Chad. Then you're going to take this boy, 5, 1, 3, divide by 1. By 4. And now what would that give you?
128.25.
128.25.3 amps. You're going to take this one to 310.15 B16 under 75-degree column. How many conductors and what size? One conductor. What number size? Number 1 AWG. And how many sets? 4 sets. 4 sets. Okay, up to this point we're cool, except we have one little problem. Can you parallel number 1? What's the minimum conductor that you can parallel? 1 not? Did you guys hear me now? So that will force you to go where? Why not? So I'm going to write here because of paralleling, I need then 4 sets of 1 conductor, number 1 aught A W G T H H W. So right in here then, this conductor will be number 1 aught, and these boys, the 2 boys here would be, what did we say the 2 boys, 600? 600 kcm in 1 conduit. Can you guys see that? 4 runs.
That's for the neutral.
That's for the neutral.
So we're using 310.15 instead of the 220.122 for the.
Say it again. We use
We don't use the 250.122 then for that one.
250.1. Yeah, there's no overcome protection device on the neutral. We're just sizing the cable. The neutrals, we don't have a fuse for the neutral, right? It lands on a log. That's why we don't size the fuse. 240.6 and all this good stuff. If I understood you right. Any comments, guys? Did I understand you right, Aaron?
We were doing it grounded before, but this is the neutral, not necessarily grounded.
Sorry. Yeah, 250.122.
Yeah.
That's for the equipment grounding conductor. This one is for the grounded conductor. Before I leave you guys, I know, Aaron, you didn't cover this one. There's 3 conductors, very, very important to understand. Ungrounded conductors are the hots. Grounded conductors are the neutrals. Grounding conductors, equipment grounding conductors, that's the ground. Okay? That's all right, but I know that it's because they're all related to the ground. Ungrounded, grounded, and grounding. They're all related to the ground. So it's
I just want to make sure I'm right.
you're right. Yeah, if I'm asking you for the equipment grounding conductor, which I'm not. Okay? I don't want to use the second step, guys, the main bonding jumper. I'm not asking you to use the main bonding jumper, so I'm not going to do that one. Okay, so let me go back into my system here and write what we came up with, and then we'll let you. Okay, so here you go. So let's just update this. So what was the size of this panel? 1600 amp. What was the size of the overcome protection device? 1600 amp. What was the size of the conductors? 4 sets of 2 conductors, number 600 kcm THHW, and 1 conductor, number 1 aught AWGTHHM. That's what engineers will write. That's what I want you guys to write me tomorrow. It's not enough to say 4 aught or 1 aught. How many and what insulation?
Why didn't you use THHW for the neutral?
THHW. I'm sorry. This should be W. That's a mistake. Thank you. You guys are with me. Huh? Yeah, we have 4 sets to get me to 1600 amp. One set will get you close to 400 amps, but I need 1600 amps, so I have to have 4 sets. Any question, guys? That's your test tomorrow. Before, let me just